Robotik in der Industrie. Der Podcast mit Helmut Schmidt und Robert Weber. Hallo, liebe Zuhörerinnen und Zuhörer. Willkommen zu einer neuen Folge unseres Podcasts Robotik in der Industrie. Und ihr wisst, unser Partner des Robotik-Podcastes ist KEBA Industrial Automation mit ihrer Robotiklösung Keymotion. Und das Besondere an dieser Robotiklösung ist, sie hat stets die richtige Performance. Wir sagen Dankeschön und jetzt geht's los. Und an dieser Stelle switchen wir jetzt ins Englische, because we have two international guests, Torsten Kroeger and Bischoff from Intrinsic. Hello, Torsten.
Hey, Robert.
And hello, Rainer. Hello.
Hello, Robert.
And a warm welcome to my co-host, Helmut in Munich. Hello, Helmut.
Hello to all of us.
So, the first products are announced. Congratulations on the presentation, Torsten and Rainer. Now everything must be sold, but before we start discussing what you want to sell, please introduce yourself briefly to the listeners. Rainer, would you please start?
Yes, happy to. Rainer Bischoff. I'm a long-term roboticist. Actually, have been working for 19 years for Kroeger before I came to Intrinsic 2.5 years ago. And now I'm responsible for the team in Munich as a general manager, Germany for Intrinsic.
And Torsten.
First of all, thank you so much for having us. It's a pleasure to be here. Really looking forward to this conversation. My name is Torsten Kroeger. I'm here as a CTO of Intrinsic. I've been in the robotics industry for more than 2 decades now, and I have the honor to serve and lead this team on the engineering side.
And now you want to democratize the robotics. Torsten, before you presented your Intrinsic robotics platform today, before we talk about the first concrete product, what should happen on this platform? Can you describe it? Is it an operating system, an ecosystem with whom? Can you please describe the strategy on this platform?
Let's start with the mission, and you've seen that in the product keynote. Our mission is to democratize access to robotics, and I would like to emphasize access here. There is no doubt, and I'm sure the entire community is well aligned on this, that we have made a lot of progress when it comes to advancing the field of robotics, for example, by adding more and more sensors, by adding, for example, machine learning methods, deep learning for perception, only to name one. And then also on the actuation side, to do more and more complex things instead of just thinking of a robotics application that needs to be pre-programmed, to have robots becoming more responsive to their environment so that they can move from fully structured environments to, let's say, semi-structured environment, and maybe eventually fully unstructured environments. And now one of the challenges that we aim to address is to make this more accessible, to make such systems easier to program, much easier to program, so that for at least one vertical, for a subset of applications, looking at tools where people who have expert knowledge about an application, about a process, they can leverage that knowledge, that domain expertise that they have, but they do not necessarily need to be an expert in machine learning or computer vision or robotics to then leverage robotics as a tool.
So, but would you come back to this platform idea? What should happen on this platform you presented?
So we do not believe that there's going to be any one single player who will be able to advance the field. Even the largest enterprises on this planet will not really be able to do this. And here's why. If you think of, and let's maybe even to make it simple, limit it to industrial manufacturing, which is obviously just a subdomain of robotics, and obviously a subdomain that is very relevant to the audience of this podcast. There's so many different applications, so many different varieties. Think of starting with welding and gluing and polishing and assembly and many, many more. You need so much domain expertise for each of these applications that, let's say for us, let's say Intrinsic wanted to be able to do that. We probably would need to hire like 10,000 people just with that domain expertise. And even then we might not be able to cover all applications that you can find in today's industry. Now, the goal here is rather to empower developers, and at the first step, as you have seen in the keynote, is to look at solution designers, solution builders, and to empower them so that it will become easier for them to build such solutions for their customers.
So is it this platform, because a lot of platforms are in the industrial sector, and let's say they are rather less successful in the moment. What is the idea? Is there then an operating system, and you guarantee that when a developer is working on this platform, this will work on all applications? Because this commodity stuff works, I think, in the smartphone market very well, but in the industrial sector, it's very, very difficult to do that. What is this platform? I don't get it.
Let's take a step back.
Yeah.
The term platform is probably an oversubscribed word.
Yes.
And if you ask 100 people in the industry, what is the platform from your perspective, you will probably get about 100 different answers. And I can give you my answer now. Yeah. I'm not sure how helpful that will be. Let me try to phrase this slightly differently. So the product that we announced, Intrinsic Flow State, is a development environment, it's a web-based development environment that is meant to be very intuitive. Yeah. So, for example, we're using a visual version for behavior trees, and you can use that then to access a number of assets. And by what I mean by assets is there are going to be some robots, there are going to be some sensors, some cameras, and it will be limited at the beginning. We will not cover everything, but the idea is to allow more and more assets to be added to the platform over time.
Okay.
And
but Torsten, my question would be, because I'm using the phrase to democratize the robotics also quite often, but mostly in the context to say we need to go in the direction of do-it-yourself application and integration. But you said, if I understood this correctly, you're focusing on solution builders or providers, which most likely will be integrators. And this will not solve the problem that integrators will mainly become, or still are, the bottleneck for really democratize the robotics field. Or is this really on the way to really make it do-it-yourself?
That is exactly what it is.
Okay.
So you may be thinking, okay, Intrinsic is an alphabet company, and they can do magical things. It's great that you may be thinking that, or maybe there are some people in the community that think that. We like to think of that ourselves, but we also want to stay very grounded. And at the end of the day, if you think about what does the end customer, like the customer, you mentioned a system integrator, which is one potential example of a solution builder. The end customer very often doesn't really care whether you use technology A, B, or C. The end customer is typically interested in quality and cycle time and throughput. Those are the metrics that matter. And with Intrinsic Flow State, and we have been working with a number of industrial partners over the years. And as you have seen in the keynote, we have unveiled that we have been working with Kroeger, which is a robot vendor, but it's also a very large system integrator. And the feedback that we have received through them is that it has become much, much easier, faster. You need less resources if you use Intrinsic Flow State, because there are also more reusable parts that you have access to in your development environment.
Maybe we should explain one more thing, Torsten, here, and this is that from end to end, we are having one tool, and this is browser-based, so that is already simplifying the access. So from the design of the work cell to the simulation of a program, to the building of the program, to the deployment, and then the operation, everything will be done within one tool. And this is Intrinsic Flow State.
Yeah.
And this is already simplifying a lot of things. And having access to a catalog of skills, what robots can do, or having access to a catalog of perception functionality so that robots can see, that is already, again, simplifying the access to robotics. And we believe that with this intrinsic flow state tool, more and more people will be able to graphically design solutions that then are valuable for end customers. Everything is in the end based on the end customer needs. And we will have more solution builders that will be enabled by using this tool.
Sorry, guys, I want to come back one more time to this platform. Is this tool flow state a part of the first product in the platform, or is the platform more an ecosystem? You mentioned Comau, and maybe we saw in the video some others. We saw some Universal Robots and some Basler stuff, or is it more an ecosystem? And the flow state is one tool, and we can there will be a next tool, and there will be a third tool, and a lot of tools, and maybe it's open to have more tools from other guys, only to understand the architecture of this. Torsten.
Yes, great question, Robert. Let me add some color to that.
Yeah.
So what we announced is Intrinsic Flow State as the first product which is built on the Intrinsic platform.
Okay.
So the Intrinsic Flow State is really the development environment. That, like Rainer just said, it's really for an end-to-end development experience where you can access things at the lowest level, starting at real-time control, going all the way up to the cloud in one holistic framework with a number of extension points and software interfaces that will allow, let's say, asset builders to plug in as well and provide assets. The other piece from a platform perspective comes in through the Open Robotics team that has joined us in December. So as you also know, there's and you might know that better than we do, the ROS community, which is clearly, and I don't think that anyone doubts that, the world's largest developer ecosystem, which we clearly want to support and leverage. And in fact, we're investing more also on the open source side than what was possible with the resources that the Open Robotics team had before. And the mid to long-term objective here from a platform perspective is actually to let this converge.
Okay.
So in the short term, there may be some high-value bridges, but then over time, let's say in the medium term, there will be first things where we have like deeper levels of interoperability and compatibility. And the vision is that in the long run, it will feel more and more like ROS, but with a more professional backbone, where you can then think of things like safety, security, things that you need from a productization perspective. And that's really the platform story to your question. And then on top of that, we have Intrinsic Flow State, which is the developer environment where you can access and orchestrate all of these things that you have available on the platform.
Maybe a short question on my side, Rainer, because you just mentioned the simulation tool based on Gazebo, and this was really cool, or I did like it, and quite impressive. The question comes up, beside integrators being a bottleneck, risk analysis is a bottleneck, or is sometimes a showstopper. Is it a plan also to make risk analysis via this simulation tool as a plug and play and CE certification to really make to take a additional hurdle away? If I can simulate all possible injuries with persons and interactions, I could imagine this would be a logical next step.
A great question, Helmut. And what I would like to say is maybe two answers to this. One answer is, since our platform is extensible, there might be, of course, developers who will be able then to offer tools that can actually do that. So you have to think maybe of a kind of plugin structure, so that people are able to offer these kind of additional tools or functionality to the platform. And another part of the answer might be, of course, there are great companies out there like TÜV, who would be able and interested maybe in being a partner of this platform on offering these kind of services. So this is all imaginable, but for sure we are not there yet.
But short question, because this most likely is copying universal UR+ platform. I mean, this is also a huge community of different components focusing on, of course, mainly on one robot arm, but the idea is quite similar. Besides, UR is not really making money off of this, because this is not a platform. It's a showroom. But is this a similar approach, or is this in competition, or is this in? How do you see?
I think there's a key difference here, and this is that we are robot or hardware in general agnostic. You also said that the UR marketplace is, of course, only for UR.
Yeah.
You can think of similar silos, FANUC, ABB, KUKA. They are all having their own marketplaces. One is more successful than the other, and UR definitely is one of the better examples. But in the end, it's a matter of, are we able to offer a tooling that addresses all robot manufacturers, and that is then compatible to more sensors, to more end-of-arm tools. And this is what we would like to achieve with this interoperability, and the platform underneath will ensure the interoperability of end-of-arm tools, of sensors, of robots. So we want to be robot agnostic. And once you have designed a process with flow state, this should in principle work with any kind of robot and sensor, provided that the workspace and the coverage of the sensor are similar.
Rainer, can you give us a little bit more details about flow state, and what is the sweet spot for Intrinsic there? Where do you see the sweet spot?
Yes. I would say the sweet spot really here is that it runs in a browser environment. So everyone's using Chrome these days, and everything runs in a browser, and so does our tooling here. And I really believe this is a huge advantage for everyone working with robots, from design to deployment. You can much more easily collaborate with different users because you're all sharing the same database. It's something that I would say changes fundamentally the way we are programming robots and we are building solutions.
And I want to talk about this. You mentioned this AI use case. What role does it play for you, these AI or machine learning use cases in the flow state application tool?
Yeah. So to make robots really more accessible, I think it's fundamental. Like Torsten already said before, robots have to become more flexible, and flexibility is achieved by using sensors. And our robot controller can use sensor information in real time, vision information, force torque sensor information, and then react to that. So the robot is much more easily able to have, let's say, smart functionality in terms of smart pick and place or smart bin picking solutions. You can use perception skills that we offer, but that will also be offered then by a large community. You can use collision-free path planning skills, and you can use, of course, grasping skills. So this is something that you can easily plug together in a flow chart. And today it's only us, but in the future, many developers will be able to provide these kind of skills or assets in a more broader term.
And you provide synthetic data, right, from the simulation, and you can work with this synthetic data in a real world application.
You can generate this data. I mean, usually you start with the CAD data of your work cell and of your robots, but there's also, of course, a way to use point cloud data to adapt it to the real world.
And
if I can add a little bit of color to this, to give some concrete examples where we believe this is adding value today already.
Yeah, thanks.
So AI and specifically machine learning is a core part of the offering, as you can imagine, also as you have heard in the keynote. And let's at a very high level, let's maybe make a distinction between perception or visual perception in particular. We use cameras in industrial settings and then also actuation when it comes to be it to motion planning or manipulation planning, and maybe controller parameterization even. The example that you have seen in the keynote is that pretty much without writing a single line of code, as a developer, all you need is a CAD model of an object, and you upload that through an interface, and then in a cloud-based offering, we will generate, like you said, Robert, a large amount of synthetic data to train a model. That model will then be downloaded, and it can be executed on-prem. So basically on-prem, we only run inference, the model that was trained in the cloud. And what you can see is that you have a highly reliable, highly robust pose estimator, for example, or also thinking of calibration, which is another key aspect, of course. And there are obviously a number of industrial applications where robust pose estimation is going to be key. And there will also be more coming from in our offering that we will announce in the next couple of weeks and months in this space to show the utility value for customers even more. But the key message here is that we have integrated the opportunity for developers to leverage data in a more powerful way, to have like a proper data pipelines, to think of security, think of privacy, to have this built into the backbone of the system. And then from a developer perspective, like you've seen in the keynote, all you need to do to oversimplify this is to operate a mouse and do 5 clicks. I'm not sure whether it was 5 in the keynote, but it was a very small number of clicks in order to leverage this. And we believe that this is one of the things that will be attractive if you use flow state, that you don't really need to worry about the computer vision, don't have to worry about the data, don't have to worry about the machine learning piece when it comes to deploying perception systems.
But how do you deploy this machine learning model then to the PLC?
We're not using a PLC system to deploy this. On-prem, you can think of an industrial PC or think of an edge device, and you typically have a real-time component. So there's a real-time operating system that is being used. Typically, there's a non-real-time part as well. For perception, inference. So depending on your setup, you can run things on a CPU. You can run things on a GPU. You can run things on a TPU, depending on what kind of hardware the customer has or needs for an application. And that's actually something we can literally show today. And the important aspect to also refer to what we shared in the product announcement is, from a deployment perspective, everything we do runs in Kubernetes. And then we've invested a lot in really empowering and leveraging Kubernetes here, because it adds a number of advantages from a deployment perspective, so that you can basically run your software in a very decentralized way. It offers a lot of flexibility from a user's and from a developer's perspective.
And this flow state, is it the pipeline for the ML ops then also?
It's definitely the front end through which you are able to upload the CAD data to the cloud, where then the models are trained and then downloaded again. So via flow state, you can access the strengths of the machine learned image processing. Okay.
You mentioned, Peter, Helmut?
I have a question additional, because you just mentioned you want to be a agnostic system. You mentioned you have in real time communications. There are some of robot manufacturers who are open to have control on their robot arms, and maybe losing or not losing their CE certification, and some are not open. How are you solving these problems really? If you want to be agnostic, and if you want to interaction in real time with these robot arms, you need to have you need to have a clear integration into these robot arms. Is there a change happening on KUKA's, Universal Robots, Fanucs, and all the suppliers to really open this? Because to give away some of their USPs?
Yes. So what I would like to answer here is that we are having two variants of our robot controller. So one variant is what we call augmented. This is basically our controller running in a box next to the box of the robot manufacturer.
Okay.
And then we are using streaming interfaces that are either publicly available from the robot manufacturer or that we would define in a partnership together with them. So this would be then a much more tighter integration. And then there's the other approach that we would offer. I would call this a control framework. And this framework can be used by any robot manufacturer if they want. So this would take away the burden of the plumbing that someone needs to add to a robot controller, and which is not really value add for a robot manufacturer. So they all have difficulties in developing a software system, a platform that is modular, as Torsten said, that is secure and safe. And this is something that we would offer to robot OEMs to take away that burden of the plumbing, so that they can focus on their strengths of building dynamic models, of building kinematic models, of building trajectory generators. So these are then components that can be built into this framework. And that's why we would call this variant integrated version of a robot controller. So these two avenues of robot control are possible. And we will start also with these two ends. So on the one hand side, there's these public available interfaces that we can use. But as you have seen, we are working also with Comau. And here we are on a much more deeper integration regarding the robot controller.
But who builds these boxes for you, Rainer?
That is again agnostic. So we can give you a recommendation what kind of industrial PC you can use. But in the end, as long as real-time conditions are met, you can use any industrial PC.
Okay, and you mentioned this Comau integration, because there's I think Comau is you go via KEBA controller, because I think KEBA is the main control unit in the Comau, right?
I think I cannot comment on that.
Okay, what is? Can you explain why Comau? Because the Italians are very strong in the automotive industry. Is that the key focus, Torsten? The automotive industry?
That's a fantastic question, Robert. Like I said at the beginning, we're focusing really on solution builders. This is the first customer group that we're looking at, and then they may have their own customers. And that might be the automotive industry. And as you know, Comau is not only a robot vendor, it's also a very large system integrator. But we're also working with other partners, other customers, also solution builders, and they are not serving the automotive industry. And in fact, we do believe that there are other industries where there's more growth potential, more greenfield applications, where the enabling technologies that are going to be coming in the next couple of years, specifically enabled through machine learning, be it by adding more perception, be it using, for example, reinforcement learning for skill parameter optimization or motion planning, that there are other industries where there's more growth potential. But automotive industry is clearly also one end customer of our partners. Yes.
You mentioned,
but coming back to this, because of course everyone is focusing or tries to focus on automotive. But you just mentioned, if I see all the cobot manufacturers and now the big players as well, they go to SMEs, small and medium sized companies, to democratize and to really grow in higher volumes. Of course, the units are piece by piece and not thousands, but the variety of applications and differences and solutions you are offering is, of course, a much wider variety. And I assume, using the ROS community, using your solution builders, normally the SME should be priority number one to to have a faster growth besides automotive.
Yes, I'm totally not disagreeing with you, Helmut. That what you said makes entire sense and resonates a lot. The message I wanted to convey is that right now, flow state is designed for solution builders, and we are looking at a number of potential end customers for them. When we're not limited to the automotive industry, but we're also not limited to only SMEs. It will really also depend on the solution builders that we're going to be working with. And because at the end of the day, what we want to do is we want to add value to them, because otherwise, there's what's the point of using us?
Rainer, I want to come back to this Comao topic, and there was this modular cell approach. You have realized what is so special about this modular cell approach they mentioned in this presentation?
Yes, so you're referring to a rigid body assembly. This is more the large field of what we believe is also one of the future, let's say, domains where we have to become active and where sensor-based control makes sense. So you saw that we have been using our perception technology, the pose estimator, to pick up one rigid body, so one part of the PHEV vehicle, and that part was then inserted on bolts. And therefore, we needed not only the perception part, but then also the force torque-based insertion of that part. And of course, you can then always verify with the perception whether you have achieved your target. You can use a nut runner to screw that part to another rigid body of that vehicle, so that in the end you have a joint two pieces together with two robots. Okay. And I think that's special because you can program this from one flow chart and in a very easy and transparent way.
Okay. Torsten, I have one more question. You said this reinforcement learning approach. Are these add-ons and AI small SDKs you want to add then, or want to sell models in the platform to your customer, or will it be a part of the flow state and you can pay for it? Is there a business model on this?
So the reinforcement learning piece was one example that you can use, for example, for skill parameter optimization.
Okay.
And this will also be accessible through flow state.
Okay.
On the business models, we're not yet ready to comment too much on that. Obviously, Intrinsic is a for-profit company. Yeah. But it is at this point not fully decided yet how we're going to be looking at business models. It's very likely that there will be a free version because we want to rather validate that we can actually add value to users now. Like I said, specifically starting with solution builders, and then learn from that so that we can actually improve and add even more value. For them, and then eventually also for end customers.
Okay. Helmut?
Short question, because you also mentioned, of course, many times the word solution builders. But what currently is happening out in the market is many startups just starting as solution builders, focusing on only pelletizing, only screwing, only welding. I mean, there are hundreds startups out there who saw exactly this kind of opportunity. We need to focus on one solution to really scale up.
And I think here comes the main point. Yeah. All these startups, they are so amazing with their solution competence, but they all have to build a platform, something on which they can base whatever they develop. And we would like to take, let's say, that plumbing burden from all these amazing startups, so that they can really focus on their expertise for pelletizing, for bin picking, for pick and place, so that they can really focus on that value add and not spend all their resources on the plumbing, on the infrastructure.
Okay. What is the next product on the platform, Torsten?
Let's get one thing right, and then we can talk about the next one.
Okay.
And Automatica.
Yes, so we will be, like you have learned in the keynote, we will be exhibiting at Automatica in Munich during June 27th and June 30th, where you will be able to kind of experience state flow. Flow state.
Flow state, yeah.
Where you will experience flow state, and you will also see a number of applications, and including one fairly large one that we have been working on together with Kumau, and also the pieces about perception that we have mentioned. You will also be able to see and experience this firsthand at Automatica.
At the end, I would be interested, how do you manage these barriers between these Mountain View IT guys and the OT guys from the robotics? Do you often argue in the team, Rainer?
That's an excellent question, but I don't want to put any dividers between the Munich team and the Mountain View team, because we are one team. That's really clear. So we are working together across time zones and across the Atlantic. And it's really a pleasure to see how that works. Yeah. Because we need some independence, let's say, in Munich to also have a healthy work-life balance in the end and not work at nights. Yeah. But in the end, we are one big team, one family that is developing that product. And we are also proud what happened yesterday with our announcement. So now we can really see what has been going on under the hood for the past years.
Yeah, but what about the arguing about IT and OT?
That's also an excellent question, but I think there's not so much arguing within the team. I think this is more like an arguing outside of us. So we believe that OT and IT have to converge. So we would like to make it also possible then for a programmer to use PLC as in the same way as they can use robot controllers. So it should in the end not matter whether you open or close a gripper via a PLC or directly from a PC, because we believe that all these skills that you need on the OT or IT level, they will be skills and can be easily assembled in flow state.
Let's ask the IT guy from Mountain View, Torsten. What about the OT guys in old Europe?
So on this argument question, Robert, and I'm not kidding. Very, very honestly, I'm not aware that we have had any internal argument. And let me even add one aspect to that. It was actually a conscious decision to start in Intrinsic in Germany and in California, because from a talent perspective, we believe that in order to be successful, we need the best of both worlds. There's without any doubt amazing talent available in Germany, like you said, especially with OT background, and like Industry 4.0 is another topic that is way more challenging to find here in California, or even if you think of functional safety, very challenging to find great talent here in California. Whereas when it comes to software infrastructure, when it comes to machine learning, it's almost the opposite. That you find like way more efficient teams here in the San Francisco Bay Area. And in order to make a step forward, and like Rainer said, the intent here is to think of a convergence of IT and OT. We need actually both teams on both continents in order to be successful.
Okay. Helmut, last question.
Last question was, you showed for the next 6 to 8 weeks these production cells or these test areas you are asking for
participants.
Participants, most likely to get a POC. Are these also then shown at Automatica as a showcase? Most likely not, because time is too short. But is this a kind of proof of concept, or what is the idea behind this? Because it sounds interesting, but
I think you're referring to the private beta that we announced.
Yes, exactly. That's what
you can apply for the private beta, and that will only start after Automatica.
Okay.
So then we are assembling cohorts of developers that will test and experiment with flow state on some use cases that we have thought of, and they can also bring in their own ideas into this.
That's what I thought. Okay, cool.
Okay, thank you very much. It was a pleasure, Rainer.
Likewise. Thank you, Robert. Thank you, Helmut.
Thank you, Torsten, and greetings to California.
It was a pleasure, yes.
Thank you so much for having us. This was fun. Thank you for hosting us, and happy to do that again. Should there be any interest at some point in the future, when we have more to show, and I can already share that there are going to be more announcements coming further down the road.
We are looking forward.
Cool to hear.
Yeah, perfect. Thank you. Bye-bye.
Bye.
Bye.
Thank you.